Hey guys, here's a video just kind of walking you through this last theorem, the Triangle Inequality Theorem. It looks more complicated than it really is. Here's what it says. The sum of any two sides of a triangle is greater than the third side length. So essentially it means you can't just take any three random lengths, any three random numbers that represent the lengths of a segment and put them together to make just any triangle that you want. Here's what I mean. Just check out this visual. Let's say we actually measured and made this, 10 feet long. Let's just make up numbers. And then I have a smaller piece that's only 1 foot long attached to here, and I'll try to draw it to scale. Well, if I were to try to connect this triangle, it has to be within a certain range of numbers. I can't just put another 1 foot piece of wood there. Let's say these are pieces of wood. They're not going to connect. It's too short, right? So maybe 2 feet, maybe 3 feet. So the idea here is there are restrictions on how it works, and the way this picture sort of shows is it doesn't work for everything. So what does it work for? Well, it works when if you add two of the sides and get a number bigger than the third side. If you were to add A and B together, you will always get a number bigger than C. If you were to add A and C together, you'll always get a number bigger than B. And if you add B and C together, you will always get a number bigger than A. Now, that looks like a lot, but in actuality, you're just adding numbers. You're not really doing anything fancy to it. And on top of that, you only are really worried about the smaller sides. Like these kind of all look similar. Maybe the B is a little longer. But if you've got one of the sides that's already bigger than the other sides, then adding them together doesn't really change anything. You're really only worried about the two smaller sides adding together to be bigger than the third side. But in actuality, it'll work for all three. So let's take a look at this example. You'll see what I mean. If I were to start with the biggest side here, or the biggest length, 15 is already bigger than 12 and 8. So no matter what, if I add something to the 15, I'm going to get a number bigger than 12 or 8. Same thing with the 12. 12 is already bigger than the 8. So if I add anything to the 12, I'm going to get something bigger than 8. What I'm really looking to do is add the two smaller ones and check those. That's where I'd be worried. 8 plus 12, of course, is 20, and 20 is bigger than 15. We are good to go. I added A and B, and it got to be bigger than C. I can check the other way, right? There's nothing stopping you. You can add 12 and 15. 12 and 15 is 27. Of course, that's bigger than 8. 15 plus 8 is 23. Of course, that's bigger than 12. Of course, I'm saying it's bigger because 15 was already bigger than 12 to begin with. 12 was already bigger than 8 to begin with. So that's what I'm saying. You don't actually need to show all three as long as you add the correct ones to guarantee it. This will really hammer it home. Watch this one. 15 plus anything is bigger than 3, right? 15 plus anything is bigger than 9. So if I add the 15 to 3 and 15 to 9, of course it's going to be bigger than the third side. But if I add the 3 and the 9 together, that's the one I'm worried about. 3 plus 9 is 12. 12 is less than 15. So this is not a triangle. It's just three lengths, three side lengths that just don't connect. It would look like this. It would look like this. You wouldn't be able to get them to connect no matter how you like rotated this or rotated this to try to connect it. Right? If I use the numbers that are here, 3, 9, 15. So I'd have here's 15, here's 3, here's 9. The 9's too short to connect to the 3 because 9 plus 3 is 12. If I were to straighten those out, in fact, let me do that. I'll do that right here on the side. Let's actually do this one. 15, 9, 3. Right? Pretty to scale, not too bad. Right? 3, 9, 15. Oh, let me do it like this. If I were to rotate this and rotate this, they'll never touch. In fact, if I rotate this all the way down to here where that's 3, and this one all the way down to here where that's 9, you can see it already. 9 plus 3 is 12. That's too short. There's too much space in between. It's not going to connect. And that's the idea behind the triangle inequality theorem. Any two sides added together have to be bigger than the third side. Now, that's not the only type of question they could ask. They could ask a question that looks like these on the bottom, where they're not actually looking for a particular length, but they're saying, find the possible side length. So it's sort of like a range of values. They give you two of the sides, and they want the possible lengths of the third side. So they give us 2, 14 and 10. So the way this works is, remember, any two sides added together have to be bigger than the third side. So 14 plus 10 is 24, right? So this has to be bigger than the third side. Let's call the third side x. X has to be smaller than 24 because 14 plus 10 is 24. So the third side has to be less than 24. That's how that will work. Just like it worked up here, right? 8 plus 12 is 20. That has to be bigger than 15. If this was 20, it wouldn't have worked. If this was 21, it wouldn't have worked. So if x is bigger than the numbers added together, it doesn't work. So I have to make sure x is smaller than that number. But I can't just make it any number smaller than 24, like 0 doesn't work, -5 doesn't work. Then you start to ask yourself, well, what would work? Would 1 work? Would 2 work? Would 2.5 work, right? It doesn't have to be a whole number. And you'll end up getting down to, well, look at the numbers. Something plus 10 has to be bigger than 14. Well, what number plus 10 gets you 14? 4. 4 plus 10 is 14, but that's not enough. It's got to be bigger than 4. If I pick 3, look what happens. 3 plus 10 is 13. That's too small. If I pick 4.5, watch what happens. 4.5 plus 10 is 14.5. That's bigger than 14. So the way it works is to get the upper bound, you add the two sides. And to get the lower bound, you subtract the two sides. And when I say the two sides, it's really for the, hang on, I blocked off there. It's really the two sides that are given for this specific type of problem. And again, if you think about it, you almost want to think about what would make it not work exactly, and then just make sure it's not that. So like 14 plus 10 is 24, so I got to make sure it's not 24. 4 plus 10 is 14, so I got to make sure it's not 4. So it's got to be in between. If it was like 9, it would work. 9 plus 10 is 19, which is bigger than 14. If it was 22, it would work. 10 plus 14 is 24. That's bigger than 22. And that's how you do it. So for this last one, 23 plus 17 is 40, so it's got to be less than 40. And 23 minus 17 is 6, so it's got to be bigger than 6. And you can spot check it just to make sure. Pick 10. If x is 10, 10 plus 17 is 27, which is bigger than 23. If x is 7, 7 plus 17 is 24, is bigger than 23. What if x is 35? That's the bigger one, right? 35. 23 plus 17 is 40, which is bigger than 35. So they're kind of easy to check because you're just adding numbers. You just have to know which numbers to add and what the relationship is supposed to be. And it all comes back to this. If you add any two sides together, you're always going to be bigger than the last side. And that's the last theorem we need. Be sure and let me know if you have any questions. You should be okay to try those problems now if you haven't already. And have a great weekend if I don't see you. Bye.